Good morning, children. So welcome back to the online session of the mathematics class. We know that we are discussing about the lesson Heron's formula. So Heron's formula, as we have discussed from your earlier three sessions, we know that Heron's formula is to find out the area of a triangle, right? Area of a triangle. So to find out the area of the triangle, we have a basic formula, that is half into base into height. So in some of the triangles, it is very difficult to find out the height. For example, scaling triangles. So there it is very difficult to find out the height. So at that time, we can make use of the Heron's formula, which uses the sides, length of the sides of a triangle. By using those values, we can able to find out the area of a triangle by using Heron's formula, right? So we have discussed those things in our earlier sessions. So in today's session, we will discuss about the application of Heron's formula while finding out the area of a quadrilateral. So before that, if we are having a quadrilateral, suppose it may be a rhombus or it may be a square, it may be a rectangle, right? So there we have some particular formula to find out the area, right? So if it is a square and if it is a rectangle, then it is very easy to find out. We can use the direct formula. If it is a rectangle, we can use a direct length into breadth, that will use the area. If it is a square, then side square, so that will also use the area. So if it is a rhombus, then we need a height. So sometimes it is very difficult to find out the height. They are not given the height in the question. It is difficult to find out the height. So at that time, what we do, not only for the rhombus, it may be a different types of quadrilateral. So we know that what are the quadrilateral. We have even a parallelogram, we have rhombus, we have then so many quadrilaterals. We have types of quadrilateral, right? So we can make use of this Heron's formula to find out the areas of quadrilateral also. Where it is very difficult to find out the height. Okay. So what we will do, they will give the quadrilateral. We will convert that quadrilateral into two different triangles. Then we can find out the area of two triangles. That's it. Because Heron's formula, it's not for the quadrilateral. Heron's formula is for finding out the area of triangle. But if they are given the quadrilateral, convert that quadrilateral into two triangles. Okay. Then we can apply the Heron's formula for each triangle. Then we can find out the area for both the triangles. Then to get the total area, we can add those two areas. Right. That will use the area of the quadrilateral. So in that way, we can use the Heron's formula to find the area of the quadrilateral. Okay, that is applications of Heron's formula to find out the areas of quadrilateral. Okay, so that will be discussed. We will take an example and we will see how we will use the Heron's formula to find the area of a quadrilateral. Okay, so the example is a part in the shape of a quadrilateral ABCD as angle C is equal to 90 degree. Okay. AB is 9 meter, BC is 12 meter, C is 5 meter, and AD is 8 meter. Okay. How much area does it occupy? So angle C is 90 degree. Angle C is 90 degree. That means this is C. This is 90 degree, right? So angle C is 90 degree, right? Then C to D, either we can take this as D or this as D. C to D is how much? 5 meter. This is 5 meter. This is C to D. Then D to somewhere else. A to D, 8 meter. So A to D, 8 meter. So let me take this as 8 meter. So this as 8 meter. Okay. Then A to B B, B to C. Okay. A to B. A to B is 9 meter. A to B. So this is B. This is 9 meter. Then B to C is 12 meter. We could have written. This is the biggest side, right? So this is A to B. This is B to C is 12 meter. A to B is 9 meter. Okay. Now this is the data they have given, right? According to the data, I have written the quadrilateral, both sides. You can observe that. This is the park. A park in the shape of AB, CD. In that angle C is 90 degree. Angle C is 90 degree. AB is 9 meter. A to B is 9 meter. B to C, C is 12 meter. C to D is 5 meter. And A to D is 8 meter. How much area does it occupy? Now it is a quadrilateral. Now it is a quadrilateral. How to find out the area of this triangle by using the Heron's formula? Okay, so very simple. What we will do? We will convert these two triangles, this quadrilateral into two different triangles. So to convert into two different triangles, what I will do? I will connect from B to D. I will connect from B to D. Now you can observe that ABD is one triangle. BCD is another triangle. In fact, BCD is a right angle triangle. Observe that BCD is a right angle triangle. One angle is 90 degree. Okay. So I have one right angle triangle, one scaling triangle. Look at this is different sides. 8 meter, 9 meter. I don't know the value of this side of this. Right. So this is. I have two triangles. Now I have two triangles. I can find out the area of these two triangles separately. Then I can add these two areas, then I will get the total area of the quadrilateral. Very simple. So look at this right angle triangle BCD. This is BCD is a right angle triangle. Do I need to find out the area of triangle by using Heron's formula for the BCD? No, not necessary. Because BCD is a right angle triangle. BCD is a right angle triangle. If it is a right angle triangle, the basic formula is enough. What is that? Half into base into height. If it is a right angle triangle, then the basic formula is enough. Basic formula is enough. No need to use the Heron's formula. What is the basic formula? Half into base into height. That is enough. Right? So what is the base? If I consider triangle BCD, BC is 12 cm. That is the base. Height is 5 meter. That is the height. So we know the base, we know the height. I can find out the area of triangle. This very easily. BC. Now comes to the triangle ABD. Okay. There it is a scaling triangle. We don't have a base and we don't have a height. It is very difficult to find out the height. There we need to use the Heron's formula. But the thing is, I know this side, but I don't know this side. BD. I don't know this. So if I want to use the Heron's formula, I should know all the three sides, length of all the three sides. But this side is unknown here, right? But this BD is a common side for this triangle also, ABD also, as well as BD is a common side for the BCD also. Since it is a right angle triangle, by using Pythagoras theorem, if I know any two sides, I can find out the third side. By Pythagoras theorem, right? So let me do that. By using the Pythagoras theorem for the right angle triangle BCD, I can find out this. Right? Then I can make use of the Heron's formula for this. Okay? Let me do first step by step. Okay? In triangle BCD, by Pythagoras theorem, okay, I'll write BCD. So this is B, C, D. This is 90 degree. This is 12 meter and this is 5 meter. This side I should find out. Okay. So this is what 90 degree on the side which is not directly connected with 90 degree, which is the hypotenuse side. We know that BD is the hypotenuse now, right? So if you find out hypotenuse side, that is enough to apply the Pythagoras theorem, because square of hypotenuse is equal to sum of the squares of other two sides, right? That is the Pythagoras theorem. Square of hypotenuse is equal to sum of the squares of other two sides. Okay. So only thing is we should find out the hypotenuse. How to find out the hypotenuse side? Look at the 90 degree angle. Look at the 90 degree angle. So the side which is not connected with the 90 degree directly. See that side BC is connected with 90 degree. DC is connected with 90 degree. But BD is not connected with 90 degree directly. So BD is the hypotenuse. BD is the hypotenuse. Okay, we will do that. Square of hypotenuse. BD square is equal to other two sides, BC square plus DC square. Okay, square of hypotenuse side is equal to sum of the squares of other two sides. BD square, I remember that. BC square, BC is 12. That is 12 square. DC is 5. So 5 square. Okay, so this is 12 square. 12 into 12. What is the square of 12? We know that 144. Okay, similarly 5, 25. So if you add 144 and 25, it is 169, right? 4 plus 5, 9, 4 plus 2, 6, 1 plus 1, that's 169. This is BD square. So I am having BD square is equal to 169. I will send square to the other side. What will happen? If I send square to the other side, what will happen? Square root. Correct? Square root of the value whatever will be there in the RHS. I am sending square root of the other side. Is square root of 169. What is square root of 169? Square root of 169. So BD is equal to square root of 169 is 13. Right? 13 meter. You know that square root of 169. Right? 13 meter. So BD is equal to 13 meter. So this is 13 meter. So B to D is equal to 13 meter. So now we can easily use the formula to find out the area of this, also find out the area of this. I know all the three sides here. AB 9 meter, BD is 13 meter, and AD is 8 meter. I can use the Heron's formula for this triangle ABD. I can use the normal formula for the right angle triangle. If it is a right angle triangle, then the previous one, the earlier one formula is enough to find out the area of triangle. And of course, we can use the Heron's formula also. Of course, we can use the Heron's formula also for this triangle also. Okay, but the earlier one, it is enough. It is a simple formula. Just taking base into height divided by 2. It is very simple. So therefore, I will be using the basic formula. Okay. So let me do that now. Area of triangle BCD is equal to half into base into height. So I will write half into base. Base is BC in the triangle BCD. Height is CD. Okay. So therefore half into BC. BC is 12 into CD. CD is 5. Okay. So 2 ones are 2 6 are. So what is remaining? 1 into 6 into 5. The numerator, denominator is 1. Okay. So 1 into 6 into 5 is 30. 30 divided by 1 is 31. 30 is since it is the area, it should be a meter square. So this is the area of BCD. Put it in the box. This is the area of BCD. Area of BCD is 30 meters square. So that is, put it in the box. Now we go further another triangle, that is what? ABD. D. Area of ABD. We will use the Heron's formula. Okay, so let me take A is equal to 9 meter, B is equal to 8 meter, C is equal to 13 meter. Correct? In the triangle ABD, A 9 meter, B 8 meter, C 13 meter. Clear? So we find out the S 17 meter. 17 meter. S is equal to A plus B plus C divided by 2. What is A plus B plus C? A is 9, B is 8, C is 13 divided by 2. So 9 plus 8, 17 plus 13, 30 divided by 2. So 2 ones are 2 15s are. So this is 15 meter. S is equal to 15 meter. Okay, S is equal to 15 meter. Now we find out the area. S is equal to 15 meter by Heron's formula. By Heron's formula, the area of triangle ABD is equal to, what is Heron's formula? Square root of S into S minus A into S minus B into S minus C. Clear? Now we will substitute all the values of S minus A and S minus C. We will do the square root. S is 15 into 15 minus A is 8. Okay. 15 minus B. Okay, A is 9. B is 8. Then minus C is 30. Okay. Now we simplify this. 15 into 15 minus 9, 6, right? 15 minus 9 is 6. So 15 minus 8, 7. 15 minus 13, 2. Correct? 15 into 6 into 7 into 2. We will try to express in terms of two values, multiplication of two values, then one value I can take it out of the box, and then out of the square root. We'll continue that. When we are square root of 15, I will write it as 5 into 3. Okay. Then into 6, I will write it as 3 into 2. Then 7 as it is. Then 2. Now look at this. 3, 3. 2 times it is repeated. So 1, 3 I can write it outside. The square. 2. Then 2 repeated 2 times, I can write it 1, 2 outside of the square root. So what is the remaining inside the square root now? 5, that doesn't have any pain. 7, that is also doesn't have any pain. Okay. Now 3 into 2 is 6, square root of 5 sevens are 35. Right? So 6 root of 35 meter square. 6 root of 35 meter square. This is the area of the triangle ABD. Therefore, the area of triangle ABD, right? ABD is equal to 6 root of 35 meters square. So this, put it in the box. So we got area of triangle BCD is 30 meters square and area of triangle ABD is 6 square root of 35 meters square. So in order to get the total area of ABCD, then we should add area of this and area of this. Correct? So we'll add this now. Now area of the park is equal to, okay. So area of the park, therefore area of park is equal to area of triangle ABD is what? 6 root of 35 plus area of triangle BCD 30, right? So this is 6 root of 35. Then this is 30. So can we find out the square root of 35? Square root of 35. So we know that 35. Since it is a pair, we will use the long division method. You know the long division method, right? So this is one pair only, so therefore it is one pair. We will go with 4s are 16, 5s are 25, 6s are 36. So we have 35, right? So we can't able to take 6, we will take 5. 5s are 25, right? So this remainder 10. So what we will do? We will add this 5 here. Then 5 plus 5 will become 10. Okay. So what we will do next step? I have only remainder 10. I don't have any pair to bring it. So we will put 1 point. How many zeros will come? In the long division method, 2 zeros will come, right? So what value I need to place here and as well as here in order to get either 1000 or less than 1000. 1000 or less than 1000. So what value we need to place? Let me place 9. Let me place 9. Okay. 9. 9 9s are 81. So 9 1s are 9. Correct? I am getting 981, which is very close to 1000. If I place 8, 9 9s are 81. Remainder 9. 9 0 0 0 plus 8 will become 8. 9 1s are 9. Clear? Now what is remaining? So 9 it is 9. Here it is 1. Here also it is 0. So only 19 we have. Again, now placed again here I need to add 9. So 9 plus 9 80. Right? So this is 118. Okay? So again I have placed this point. Then I should add 2 zeros. So what value I need to place? 2 times? No, 2 times will not go. 1 time will go. That's it. So 1 1 1s are 1, 1 8s are 8, 1 1s are 1, 1 1s are 1. Enough. 5.91. 5.91. So it is 6 into 5.91 plus 30. So let me multiply this. 591 into 6. How much? 6 1s are 6. 6 9s are 54. So 6 5s are 30, 30 plus 5, 35. Correct? So how many places? 1, 2, so 2 places. Which is 35.46. 35.46, right? Plus 30. Understood? Square root of 35. 6 square root of 35 plus 30. Square root of 35 I find out by using the long division method. I am getting 5.91 approximately. So 5.91 I substitute in the place of square root of 35. So I have multiplied 6 into root square root of 35. So therefore 6 into 5.91. I have multiplied 591 into 6. Decimal places I have placed after that. I am getting 35.46. This is 30 as it is. 35.46 plus 30. 65.46 meters square. This is the total area of the park. 65.46 will become the area of the park. Okay. So like this we can be able to find out the area of a quadrilateral by using the Heron's formula also. Okay. So that's it for today's class. I will give you one more exercise 12. Exercise 12.2. Second one is the homework for you. Second question. Do it second question. First one I have done that. This is the first one. Second one will be the homework for you. Very, very simple question. Everything they have given in the data. Only thing is you should draw the diagram. Okay. After drawing the diagram, you have to look at the diagram. You will be divided into 2 triangles. So 2 triangles. Find the area of 2 triangles by using the Heron's formula. Okay. So do that. That is the homework for you. That's it for today's class. We will continue the lesson in the next class. Thank you.